question 2A and B, something like that. So question 1 reads, the specific heat of ethanol, they've given us the specific heat of ethanol to be 2.45 joules per gram degree Celsius. And its density is 0.852 grams per milliliter. How much heat is required to raise the temperature of 62.0 moles of ethanol from negative 8.0 degrees Celsius to 40.0 degrees Celsius? So how are we going to deal with this question? Because remember, the formula we said we're supposed to use is this one. We said Q, or change in Q, is equal to mass multiplied by C multiplied by your change in T. So we've been given the change in T, which is going to be what? It's going to be 40 minus negative 8. That is going to be our change in T, which is giving me 48 degrees Celsius as my delta T, this guy here. Then the C, which is the specific heat capacity of ethanol, they've already given it to us to say it is 2.45 joules per gram degree Celsius. The mass, they haven't given us the mass of our ethanol in this question, but what are we going to do? They've given us density, and they've also given us the volume of our ethanol. So, you know, to say the formula for density is equal to what? Is equal to mass over volume. And if we rearrange this formula, I'm sure you are able to tell to say we can get our mass of our ethanol from this formula. So we're going to say mass of our ethanol is going to be equal to our volume multiplied by density in that manner. So let's find our mass of our ethanol. Okay, so mass of ethanol will be equal to 0.852 multiplied by 62 itself. Okay, so the mass of our ethanol is equal to where is this? Okay, the mass of our ethanol is equal to 52.824 grams. So the mass of ethanol is going to be 52.824 grams. Okay, so that is going to be our mass of the ethanol. So if we've gotten the mass of the ethanol now, we know our temperature difference and we know our C. You can see that we can now get our heat, which is required to raise the temperature of our ethanol directly from this formula that we have here. So we're going to have the following. Okay, so we're going to say Q is equal to MC multiplied by delta T. So our Q is going to be M, which is 52.824 multiplied by the heat capacity, which is 2.45. 2.45 multiplied by the change in temperature, which is 48. So if we multiply these three values, we're going to get 2.45 multiplied by 48. Okay, so we're going to get our Q, which is the energy required to be equal to 6,212.1 joules of thermal energy, of which this can also be written as what? As 6.2 kilojoules, which can also be equal to 6.2 kilojoules of thermal energy. So that will be the thermal energy that is going to be required in order for you to change the temperature of that of this volume of ethanol, which is 62.0 mils, with the density of 0.852 grams per mil, by a temperature difference of 48 degrees Celsius, which is from -8 degrees Celsius to 40.0 degrees Celsius. Okay, so I hope there is no question there on question 1. The next question is question B. So question B is saying a liquid of specific heat capacity 3,800 joules per kg per Kelvin rise from 20 degrees Celsius to 80 degrees Celsius in 3 minutes when an electric heater is used. If the heater generates 70,000 joules per minute, calculate the mass of the liquid. Okay, so this is also a very interesting question because they are telling us to say uh, we have this liquid which has a specific heat capacity of 3,800 joules per kg Kelvin, and then it has a temperature difference which is equating to 60 degrees Celsius, and it heats, or this temperature rise takes place in 3 minutes when an electric kettle is used. So if a heater generates 70,000 joules per minute, calculate the mass of your liquid. So let's collect our data. Let's collect our data. This is question B. So we have specific heat capacity, which is C, and this is equal to 3,800 joules per kg per Kelvin. Then we've also been given thermal energy, which is Q, that is generated. So they've said it's 70,000 joules per minute. Per minute, this is the energy that is generated by the electric kettle, but they've given us time to say this generation of power is taking place for how long? For 3 minutes. Okay, and what else have they given us? Okay, they've given us the change in temperature. So they've said the change in temperature which is taking place is from 20 degrees Celsius to 80 degrees Celsius. So we also have change in T, or delta T, which is 20 to 80 degrees Celsius, of which 80 minus 20, we're going to get a change in T, or delta T, of 60 degrees Celsius. So if we bring our formula for finding specific heat capacity, we're going to agree with me to say it is going to be in this manner. Q is equal to MC multiplied by your change in T. So if this is the formula we've been given, understand to say they've already given us the thermal energy, or the thermal energy that is generated, and they've said this is 70,000 joules. in 3 minutes. Then they've given us, oh, we are looking for the mass of the liquid. They've given us the specific heat capacity, and we also know the change in T. We've said this is 60 degrees Celsius. So how are we going to go about this? So we can just rearrange the formula and make our mass the subject to the formula. But before we do that, we have to make sure to say we find the correct thermal energy, because they've told us to say 70,000 joules is generated in how much? In 3 minutes. So we're supposed to find the overall energy first before we started, or before we start replacing anything in the formula. Let's find the total energy that is generated. So if this 70,000 joules is generated in 3 minutes, how much of energy is that going to be? So we're going to convert our 3 minutes into seconds. So 3 multiplied by 60, which is giving me 180 seconds. So 180 multiplied by 70,000. And that is giving me 12 million. Okay, so I'm getting 12 million 600,000. 600,000 joules of thermal energy. So this is the amount of thermal energy that is going to be used in this time frame of 3 minutes, that this liquid is going to change um, its temperature from 60 to 80 degrees Celsius. So let me check if there's anything that we need to do now. Okay, so they've given us to say, okay, so they've given us the units in Kelvin. They've given us the units of specific heat capacity in Kelvin, and they've given us the temperature in degrees Celsius. So there's a contradiction in the units there. So I have to make sure to say we convert our value of temperature into Kelvin. So how are we going to do that? We are going to convert our 20 degrees Celsius into Kelvin and convert our 80 degrees Celsius again into Kelvin, so that we can find a common temperature, which I expect us to have almost the same thing. I think we're supposed to have the same 60. So I'll say 20 plus 273. Okay, so that is the initial temperature, 293. Then we have 80 plus 273, which is giving us 353. So 353 minus 273, it is giving me, 293, it is giving me the same 60 Kelvin. So we are going to use 60 Kelvin instead of degrees Celsius. Okay, so now the question has even become much simpler. Much simpler. Okay, so I'll now bring my formula to say Q is equal to MC multiplied by the change in T, like that. So I'm making M my subject to the formula, which will give me M is equal to Q over C multiplied by change in T. So M, not Q rather. M will be equal to 12,600,000 over 3,800 multiplied by 60, which is the change in temperature. Okay, so that heat capacity which is 3800 multiplied by 60 will give me 228,000. So 12,600,000 divided by my answer. This is giving me 55.26 kilograms. So the mass of our liquid is equal to 55.26 kilograms, like this. Any question? Any question? Okay, so I hope this is clear once more. So that is going to be the mass of our liquid. So that was question 2, or question B rather. Then now let's go to the next question, which is question C. So question C is saying 2.5 amps of current, which passes through 10 ohms resistor for 28 seconds, generate heat, which is used to evaporate 12 grams of water at its boiling point. What is the specific latent heat of the liquid? 2.5 amps of current, which passes through 10 ohms resistor for 28 seconds, generate heat which is used to evaporate 12 grams of water at its boiling point. What is the specific latent heat of the liquid? So how are we going to go about this question? First, we are going to look at the formula for finding latent heat. So what did we say the formula for latent heat was? I bring you back to the formula in case someone has forgotten. On calculation of latent heat, so the formula was equal to Q being equal to L multiplied by M, or M multiplied by L. And we said that formula, this one, the M is giving us what? It's the mass of the substance that is changing state. Obviously, this mass should be given in kilograms, and L is the latent heat. Q is the amount of thermal energy that is involved. So if we go to this question here, question 2, you'll see that they haven't given us the thermal energy. They've only given us this current passing through this resistor for this amount of time. So this Q now, or this data that we've been given, is the one that we are going to use in order for us to calculate for Q. Because if a certain amount of current is passing through a resistor, there is certain amount of energy, heat energy, that is released. So that's how we are going to approach this question. We'll find the energy. Then if we find the energy now, we already have the mass of our liquid. Then we'll replace that mass into the formula in order for us to find the latent heat of that liquid. Okay, so let's go to our board. we collect the data. Okay, so we've been given to say there's current of 2.5 amps. There's a resistor which is rated 10 ohms. Then this is taking place in a time frame of 28 seconds. Then there's the mass of the liquid, which we've been given to be 12 grams. 12 grams. So from here, what are we supposed to do? Because the formula for latent heat is Q is equal to mass multiplied by the latent heat. So we're supposed to find the latent heat, which means we're going to use the formula Q over M is equal to what? Is equal to L. So we're going to divide the thermal energy that is used by the mass of the object in kilograms, which means we're supposed to convert this mass that we've been given into kilograms. And that's how we are going to get our latent heat of this object. Okay. But which formula now can we use in order for us to find the Q? So if we've been given this data of the current, the resistance, and the time, you're going to use this formula, which says power generated is equal to I squared, which is current squared, multiplied by what? Multiplied by R, of which R is the rating of your resistor. So in this case, I've been told to say the rating of our resistor is 10 ohms. But if we find power is not energy. In order for us to find the energy, we use the formula energy is equal to power multiplied by time. So you can see if this is the formula for power, how we're going to convert it into energy. We're just going to multiply this guy with the time outside there. And this should be able to give us the full energy that is required in order to raise the to change the state of this liquid. So let's get it done here. This is the end of my board. How? Okay. Oh, I've used the wrong board. All right, all right. Anyway, it's fine. It's fine. So I'll say my energy will be equal to I squared. And what is I squared? It's 2.5 squared. This is the current squared multiplied by the rating of my resistor, of which what is the rating? It's 10, multiplied by the time. And what is the time? It is 28 seconds. So I'll get the value of my energy to be equal to what? To be equal to 2.5 squared. 2.5 squared multiplied by 10 multiplied by time, which is 28 seconds. Okay, so I'm getting, let me do it again. 4.5 squared multiplied by 10 multiplied by 28 seconds. Okay, so I'm getting 1750 joules as the energy. So if this is now the energy that is required, we can now go into our other formula, and replace. Okay, so I'll bring my formula now, which was saying Q is equal to ML. So Q is 1750. What is the mass? Mass is 12 grams. So 12 grams multiplied divided by 1000 divided by 1000. That is giving me to be equal to 0 0.012. 0.012 L. So divided by 0.012, I'll get my L to be equal to what? To be equal to be equal to 145. So let me write it down here. It won't fit here. This will be equal to L will be equal to 145. 833 joules per kg per Kelvin. Or not per Kelvin, it's just joules per Kelvin. It's just joules per kg since there's no change in temperature here. Joules per kg. So that is the value of our L. And thank you for coming through. We'll continue the Torah sheet next time. Until that next time, please have a blessed night. Thank you once more.